Alright, we are going to review our exponent rules. So we're going to look at these 4 problems individually and talk about what needs to be done for them. So in the first one we have simplify, a to the 5th, b to the negative 4. And remember, when we're dealing with exponents in simplified form, we cannot have a negative exponent. So no negative exponents. So if we put this over 1 and turn it into a fraction, a to the 5th is a positive exponent. So in fraction form, we leave it alone. We don't need to do anything to that. That's in simplified form. But b to the negative 4th, that is a negative exponent. So remember, when we have a negative exponent, to simplify this, we take what is attached to the negative exponent and we move it across that fraction bar. So in this case, we need to take that b to the negative 4th and move it below, and it becomes b to the positive 4th. We do not have the same base, so this is all we can do to this problem. So this is in simplified form. Next we have evaluate, 4 squared minus 5 squared. So the first thing we need to do is remember our order of operations. We've got exponents, so we need to square the 4. Remember, 4 squared means 4 times 4. So 4 times 4 is 16. Bring your minus sign down. 5 times 5 is 25. Now we have numbers that we can subtract. 16 minus 25, we have different signs, so we are going to subtract our numbers and keep the sign of the larger number. So when we do that, we get negative 9. Number 3 is asking us to write 9 to the negative 3rd power in standard form. So that means we actually need to simplify our problem until we can't take it any further. So the first thing you should notice is that we have a negative exponent. So if I rewrite this as a fraction, I need to take 9 to the negative 3 and move it to the bottom. And this becomes 9 to the 3rd power on the bottom, and then we put 1 as a placeholder on top. But because it's asking us to write it in standard form, we are not done at this point. We actually need to multiply it out, which means we are going to say 9 times 9 times 9. And that gives us 729. So our final answer is 1 over 729. The last problem on this page has 2 different rules we're dealing with. We have x to the 0 power. And remember, anything to the 0 power equals 1. So in this case, x to the 0 power simplifies to 1. So I could rewrite this as 12 times 1 times y to the negative 5th. Well, 12 times 1 gives us 12. So we're left with 12. And then again, I have that negative exponent with my y. So I need to move the y to the bottom of the page, or not the bottom of the page, excuse me, the bottom of the fraction, and then I have a positive exponent. And that would be my final answer. Next, we're going to look at scientific notation. So the first one, number 1, says, what is 0.000058 written in scientific notation? So we need to move the decimal so that we have a number bigger than 1 and smaller than 10. So if I move my decimal between the 5 and the 8, 5 is bigger than 1 and smaller than 10. So I can rewrite that as 5.8 times 10. Now, I need to count how many places did I move my decimal. I moved it 1, 2, 3, 4, 5 spots, and I have a really small number, so that gives me a negative exponent sign. So in scientific notation, this number is 5.8 times 10 to the negative 5th power. Now, number 2, I'm given a number in scientific notation, and the directions ask me to write it in standard form. So I actually want to multiply this out. And I can do that. I start with 6.29, and I have times 10 to the 5th power. Notice the 5 is a positive, which means I should get a larger number, and I'm going to move my decimal 5 places. So 1, 2, 3, 4, 5, and put my new decimal point. And any spaces that are empty, we are going to add zeros. Now, make sure you rewrite this number so it looks nice and neat. So I get 692,000. And this would be my final answer. Number 3 is asking me to find the product. And after I find the product, I need to make sure the answer is in scientific notation. So to do this, I can regroup my like terms. So I can rewrite this as 1.9 times 4.5 times 10 to the third times 10 to the fourth. So when I multiply 1.5 or 1.9 times 4.5, that gives me 8.55. And I can use my exponent rules to combine my bases of 10. When my bases are being multiplied and they're the same, I can add my exponent. So that gives me times 10 to the 7th power. And again, you need to check your answer to make sure it's in scientific notation. 8 is bigger than 1 and smaller than 10. So I do have a number in scientific notation. So that would be my final answer. Number 4 is asking me to find the quotient of these two numbers. So just like I group my like terms when I multiplied, I can do the same for the division. So I'm going to divide 2.89 divided by 3.4. And when I do that, I get 0.85. Then I bring my times sign, 10. Now keep in mind, when I'm dividing my bases that are the same, I can subtract my exponents. So I have 2 minus a negative 2. Double negative turns into a plus, and I end up with an exponent of 4. But here, I've got a 0 is not bigger than 1. So I need to move my decimal one spot to give me 8.5 times 10. When I move my decimal one to the right, I'm actually going to subtract 1. So my final answer would be times 10 to the third power. The last question is asking me which number has a larger value. So I am going to, without actually writing it out in standard form, I can look at the exponents. I have 10 to the 5th power and 10 to the 3rd power. 5 is larger than 3, so 3 times 10 to the 5th power would be my larger value.